Hi, my name is Honman So. In this session, I will talk about a research project conducted by University of South California, USC. The aim of this project is to create a scalable dynamic demand response software platform to predict electricity demand and supply and to assist in near real time the actioning of preemptive consumption curtailment strategies to reduce consumption near periods of peak demand. The project uses the microgrid at USC as a testbed. USC has 100 diverse buildings and 50,000 students, staff, and faculty. Each building has a smart power meter and equipment sensors to monitor the heat, ventilation, and air conditioning units, airflow, and set point temperature. The microgrid at USC is highly instrumented and has the appropriate characteristic of a smart grid that will be rolled out to the entire region in Los Angeles. USC's data come from a variety of sources. Stream data come from smart meters and equipment sensor at 100 campus buildings and at 15 minutes intervals. Instantaneous data sampled hourly and daily. Historical data aggregated over several years are used for training purpose. Periodic information on ambient weather, organizational structure, building construction, scheduling, facilities, office space assignments, and customer surveys. The sources can change over time. USC developed the data flow framework to create and manage data processing pipelines on the system. A pipe A pipeline has four logical stages to handle data transport, data parsing, semantic annotation, and data storage. The ingest pipeline supports dynamic data acquisition at various rates and volume and is adaptive to current data sources and operation needs. Two main data-driven forecasts. The curtailment forecasting models are used to make predictions on potential energy reduction at 15 minutes intervals. The models allow different curtailment strategies to be implemented on buildings and customers during specific time periods. Data-driven model training. The regression tree machine learning model is used by USC and is called OpenPlanet. It is based on Google's Planet Distributed Regression Tree algorithm. OpenPlanet applies MapReduce iteratively to reduce data partitions to a certain size before switching to Weka. Weka is then used to complete the processing of regression subtrees completed in memory. Autoregressive integrated moving average time series are also used to improve high accuracy predictions. Information on energy consumption is disseminated via a web portal and Android application and can be presented both in visual and non-visual forms.